Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 2 class. It is 7.1, Day 2 notes. Today we're going to talk about some permutations with repetition. In the last unit we just talked about permutations. Now we're going to work with some things that have letters that will repeat. Okay? So how many distinguishable ways can the letters of mom be rearranged? Well, the word distinguishable, it's easier to think of it as visual ways. Can the letters of mom be arranged? Well, if I start with mom, obviously that's one way. Then if I start with that M again, I can have MMO. Then finally, if I start with O, then I can have OMM. It doesn't matter which M is at the beginning or at the end or in the middle or whatever. There's only an M is an M is an M. So there's only three distinguishable ways. Okay. So if we look at the formula just beneath this, it says the total number of objects is n. So we have n factorial, which just means if I have three objects, then I take 3 times 2 times 1. Q1 is the number of times an object is repeated. Q2 is the number of times a different object is repeated. So what's going to happen in the denominator here is I'm going to take every time that something gets repeated, I will do a factorial of how many times it got repeated. So in the word mom, I have 3 objects. So it's 3 factorial, which is my n factorial here. How many times did something repeat? Well, the letter M repeated twice, so that I have 3 factorial over 2 factorial. Okay? If I go ahead and write those out, it would be 3 times 2 times 1 over 2 times 1. Knowing what we know about fractions, I can get rid of this 2 and the 1s, and it'll leave me with 3. Okay? So the numerator is the number of objects I have, their factorial. The denominator is, say, one letter repeated twice, it would be 2 factorial. Another letter repeated 3 times, it would be 3 factorial. Another letter repeated 4 times, it would be 4 factorial. Okay? So let's look at some more of these examples. Find the number of distinguishable permutations of the letters in the following words. So I have the word summer. First thing I need to do is figure out how many letters I have. So I have 1, 2, 3, 4, 5, 6 letters. So it would be 6 factorial over. Then summer, I have M that repeats 2 times. So it would be 2 factorial. There's nothing else in the word summer that repeats. So what I'm going to do is write this as 6 times 5 times 4 times 3 times 2 factorial. Remember that 2 factorial would be 2 times 1. I'm showing you this because it'll help later on when we get to some other situations. Okay? And I'm going to leave the denominator as just 2 factorial. Knowing what we know about fractions, I can get rid of the 2 factorial. So now I just have 6 times 5 times 4 times 3. 6 times 5 times 4 times 3 would be 360 different ways that you could write the word summer. Let's look at waterfall. Waterfall, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 factorial over. How many things repeat? Well, the letter A repeats twice, so I have 2 factorial. Is there anything else that repeats? W doesn't repeat, T doesn't repeat, E, R, F, nope, but L does. So again, another 2 factorial. If I write this out, I have 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 factorial over 2 factorial. Now that 2 factorial and the 2 factorial in the numerator are going to go away, but I do still have another 2 factorial, so it'd be 2 times 1. What I want to do here is now try to figure out, is there anything in the numerator and denominator that I can simplify? Well, this 2 and 4 will simplify. The 4 will turn into a 2. So I have 9 times 8 times 7 times 6 times 5 times 2 times 3. If I multiply that all out, I have 90,720 different ways that I could write the word waterfall. On to example 3, basketball. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 letters in the word basketball, so it's 10 factorial over. Well, the B obviously repeats, so that's 2 factorial because the B happens twice. The A repeats, so that's another 2 factorial because that happens twice. Now the S doesn't repeat, K doesn't, E doesn't, T doesn't, but the L's do again. So I have another 2 factorial. So here what I'm going to do is write this out. So it'll be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 factorial. My denominator, I have a 2 factorial. I'm going to leave that as a 2 factorial because I know I can cancel the numerator and denominator. But I'm going to write out my next, which is 2 times 1, and my next factorial, which is 2 times 1. This 2 and 2 multiply into 4. Well, I know I can cancel a 4 and a 4. So I have 10 times 9 times 8 times 7 times 6 times 5 times 3. If I multiply that completely out, I end up with 453,600 different ways I could write the word basketball. Example 4, mathematics. So the word mathematics, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 letters in mathematics. What will repeat? The M's repeat, so there's a 2 factorial. The A's repeat, so there's a 2 factorial. I have T repeating, so there's also a 2 factorial. Is there anything else that repeats? No, there is not. So just like I have done every other time so far, what I'm going to do is write out my numerator until I get to the largest factorial in the denominator. So the largest factorial in my denominator is 2 factorial, so it'll be 11 times 10 times 9 times 8 times 7 times 6 times 5, 4, 3, 2 factorial over 2 factorial I'm going to keep because I know I can cancel out this 2 factorial and the numerator. So I have 1 2 factorial. Now I have to work with this 2 factorial, so 2 times 1. And my last 2 factorial, so 2 times 1. 2 times 1 times 2 times 1 can turn into 4. The 4's can cancel. So I'm going to multiply everything that's left. So 11 times 10 times 9 times 8 times 7 times 6 times 5 times 3. That would turn into 4,989,600 different ways that I could write the word mathematics. Okay? Let's move on to the back. The back is a review of our last section. So find the number of ways all the events can occur if event A has 10 ways, event B has 2 ways, and event C has 5 ways. Remember, if it gives you a number of options and it wants to know all of the ways that all of the events can occur, I'm just going to take 10 times 2 times 5, which would then get me 100 ways. There's 100 different ways that all those events can occur. All right, now we need to determine the number of possible passwords containing 3 letters and 4 numbers if they can be repeated. Remember, the number of letters is 26. The number of numbers is 10. Okay? Talked about that in the last section. If they can be repeated. So the first thing is it's going to have 3 letters. So the first choice I have is 26 letters. If it can be repeated, I still have 26 letters. And I still have 26 letters. The next thing is the 4 digits, or the 4 numbers. Well, I have 10 for my first choice. It can be repeated, so I'm going to have 10 for all of my choices. So 26 times 26 times 26. If you multiply all this out, I end up with 175,760,000 different passwords. Okay? Now, if they cannot be repeated, every time that I use a letter, it goes away. It's like I chuck it out the window. Okay? So if they cannot be repeated, I have 26 letters for my first choice. Say I use the letter A. Now it's gone. There's only 25 letters left in the alphabet. So I'm going to use 25. Say I use B for that. I'll chuck that out the window. Now there's only 24 different options for my letters. So I have 24 choices left. For the numbers, it works exactly the same way. With my first number, I can have 10 choices. My second number, I'd have 9 choices. Then I'd have 8 choices. Then I'd have 7 choices. So as you can see, when they cannot be repeated, every level past the first that I go, I'm going to drop by one choice. So if I have letters, it'd be 26, then 25, then 24, then 23. If I have numbers, it's 10, 9, 8, 7. If I multiply that out, I end up with 78,624,000 choices or passwords. Okay? On to problem 7. Well, what does 6 factorial mean? 6 exclamation point. Remember that exclamation point means factorial. All that means is that I'm going to take 6 times 5 times 4 times 3 times 2 times 1. Multiply that all out. I end up with 720 as my answer. Now 8, a little bit different. I have to make sure that I keep the 2 on the outside as I write out my factorial. Well, 4 factorial is 4 times 3 times 2 times 1. 4 times 3 times 2 times 1 is 24, so 2 times 24 would get me 48. Alright, on to problem 9. I have 3 factorial times 6 factorial. So 3 factorial times 6 factorial would get me 3 times 2 times 1 times 6 times 5 times 4 times 3 times 2 times 1. If you multiply that completely out, I end up with 4,320. Alright, on to problem 10. I have 6 factorial over 2 factorial times 4 factorial. So in this case, what I'm going to do is I'm going to write out 6 factorial until I get to the largest factorial in my denominator. The largest factorial in my denominator is 4 factorial. Well, we know 4 factorial is 4 times 3 times 2 times 1. So I'll do 6 times 5 times 4 factorial over 4 factorial times, now I have to work with my 2 factorial, which is 2 times 1. The 4 factorial can go away. The 6 and the 2 can simplify into 3 for the 6. The 2 would go away. 3 times 5 would be 15. And I'm done with that problem. Okay. On to problem 11. I have 10 permutations of 4, or 4 permutations of 10. I have 10 objects. I want to see how I can put them together in groups of 4, right? So what I'm going to do here is I have my larger number on top. Then I take my 10 minus my 4 factorial on the bottom. That would get me 10 factorial over 6 factorial. As I write this out again, I only want to write my 10 factorial out until I reach the factorial in my denominator. So it would be 10 times 9 times 8. Oops. Should be 8, not a 6. Times 8 times 7 times 6 factorial over 6 factorial. The 6 factorials go away. Now I have 10 times 9 times 8 times 7. That would multiply into 5,040. And now I have 7 permutations of 7. So here again, I would have 7 factorial over 7 minus 7 factorial. So it'd be 7 factorial over 0 factorial. We talked about what 0 factorial is in our last section. 0 factorial is 1. So it'd be 7 factorial over 1. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. So if I multiply all that out together, I end up with 5,040. Okay. Find the number of distinguishable permutations of the letters Panthers. This is what we did on the front side at the very beginning. So I'm going to put the total number of options that I have in factorials. Okay. So Panthers is 1, 2, 3, 4, 5, 6, 7, 8 letters long. So it'll be 8 factorial. This would be over any letters that repeat. Well, the P does not repeat, the A doesn't repeat, N no, T no, H no, E no, R no, S no. So it's just going to be my 8 factorial. So it'd be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Multiply that completely out, I end up with 40,320. Okay. Store owner has 13 different chairs to line up in a single line for display. If you think about this, it's kind of the same idea as only having one part of a password that we were talking about before. how many options do I have for each different section to line up the chairs. So if I have 13 different chairs, I line up the most luxurious office chair that's leather first. Well, then I would have 13 options for the first spot. Then I would have 12 for the second spot. Then I would have 11, then 10, then 9, then 8, then 7, then 6, then 5, then 4, then 3, then 2, then 1. The reason why I would have those is because I can only put a chair in one slot. I can't use the same chair in two different slots, right? So it would be 13 factorial. If I multiply that completely out, I end up with 6, 2, 2, 7, 0, 2, 0, 8, 0, 0. So I end up with 6,227,020,800 different ways that I could order those chairs. You want to remodel your bedroom. You plan to replace the window coverings, paint the walls, and change the flooring. You have 9 choices for window coverings, 12 choices for paint, and 7 choices for flooring. This is very similar to the problem from our last section where we were talking about the sandwiches I could make. Okay? So what I'm going to do is I'm going to take my 9 choices for window coverings, my 12 choices of paint, and my 7 choices for flooring, multiply those together, I end up with 756 different ways that I could remodel my bedroom. Okay? Well, that is the end of the lesson. The most important thing to remember from this lesson today is the permutation with repetition. If I have something that is repeating within a letter, how many different ways can I organize that word? Well, what I'm going to do is I'm going to take the total number of letters that are in the word. I'm going to have that that factorial in my numerator. I'm going to put that over any letters that repeat factorial, and we will work from there. Also, if you're working with a fraction that has factorials in the numerator and denominator, remember that if you have any factorials that are the same, you can cancel them just like regular numbers. Otherwise, that is the end of our lesson. Make sure that if you have any questions over any of this stuff, you come in and see me. Otherwise, thank you very much for watching the video, and have a great day.